Geometric sequences in series. Now, the difference between a geometric sequence versus the arithmetic sequence. The arithmetic sequence had the same difference. You know, you could add or subtract the same thing between each individual term. When you're talking about geometric, then they now have the same multiplier between each term. That multiplier, they call it a ratio. And that ratio could be multiplying by 2, multiplying by -3, dividing by 4, multiplying by -5/3. So you're looking at these common ratios. You're working with fractions a little bit more. You're going to find out that working with these is very similar into what we did yesterday with the arithmetic stuff. We're going to write out the rules. We're going to be given a specific term with its value, work backwards to find the first term, use it as in terms of a system of equations again, and eventually we will talk about the series. We will probably run out of time today to get to the series, which is not that big of a deal. We got plenty of time to get through the chapter. It's not that, because today is a Wednesday and tomorrow is basically another Wednesday.
Oh, that's right.
You got that.
Really weird schedule.
Another schedule.
Why are we doing that?
We still have
They're doing the the drunk driving the demo thing tomorrow.
Oh, for prom?
Yeah.
Is it like outside or something? Or is it
Well, it's tough to bring a helicopter inside, but yes.
What?
But I think we should have.
I'm sorry, right? That was just kind of easy to say it like that.
What?
Where'd you get helicopter?
You're gonna land the flight for light.
Oh, okay.
They kill somebody and then they rescue.
Yeah, the, juniors and seniors drew straws to see who's gonna get killed.
Dude, I hope I.
It's already been happened. It's already happened. And that person
He's
already.
not here. That's perfect.
It's supposed to be a surprise.
Yeah.
Daisy.
Glad I could help.
All right. So here's what happens. Yesterday we were talking about this common difference. We were using, guys. This doesn't take long. We had the common difference. We used the letter D. Today we're talking about a common ratio, so we're going to use the letter R. All right.
You should have bored a pirate.
Yeah. Anyways, so here's how we set these things up to see if they have a common ratio. And this is how it works each and every single time. In order to tell if something is geometric when you're looking at a sequence, what you do is you always work ahead of yourself. You take the second term divided by the first. Does that equal the third term divided by the second? And so on and so forth. That one doesn't work because last time I checked, that's supposed to be a 6. 2 did not equal 3. Man, I put it's supposed to be a 6. I'm simplifying these things out. Does not equal. I am sorry, guys. I don't know where I'm coming up with these numbers. 2 doesn't equal 3. 3 doesn't equal 4, and 4 doesn't equal 5. That is not a geometric sequence. Okay. That ratio isn't the same between all of them. It is a sequence. You could probably figure out what the next couple of terms are going to be. It's not that difficult to do. But it is not something that we're going to work with. Yeah. Yep.
Michael Paul?
Sure.
Oh, you killed Pollock.
Now, after that, obviously since those values are not all the same, it's not going to be geometric. So you check the other one. And you do the same thing. Is 27 over 81 the same as 9 over 27? Is that the same as 3 over 9? Is it the same as 1 over 3? Those all have the same common ratio, don't they? What is it?
1/3.
1/3. So we'd say that the common ratio here is 1/3.
Would you say it's a smart idea to start off with a smaller number of numbers in a sequence?
No, just work like you would normally. Just go right down the line. There's no smarter way of doing it. It's just that way. If you always go second divided by first, second or third divided by second, you just go that way. It works every time.
Like
SMRT.
Like Vaseline in the glove.
How does that connect to common?
Yes.
Mike said that.
Okay. So let's look at how you write out the rule, the nth term. The nth term for geometric sequences is defined by a sub n again. It's going to be that first term times the ratio raised to the power of n minus 1. What's that? You can put, you will see parentheses written around the r value as we go forward here, and that way you don't have to simplify things through. And when we do a couple, you'll see that. Okay? So your nth term rule our nth term rule here, we just look at this example. You guys told me that the common r value was 1/3. If I wanted to write this out in terms of the nth term, again, all I have to do is start with the rule. Well, the first term was 81. The rate is 1/3 to the n minus 1. And I'm done. That's it. When you first wrote out the rules for the differences, the only thing you had to do there is you distributed that d value. Here, there's no distributive property at all. You're done. That's it. Okay? Geometric ones tend to be a little bit easier to work with. Some ways. Okay? Yeah.
So, route, like the question or whatever would say here's a sequence route. So
Yeah.
it would be-
I'll show you. It's going to look like this. Write out the rule for the nth term. Just like we did yesterday. Write out the rule for the arithmetic sequence. So in this one here, we have -8, -12, -18, -27. So I want to start by writing out the nth term, which means the first thing we're going to do here, like we did yesterday, we found the difference. Now we're going to figure out what the ratio is. So you start -12 over -8. What's the r value? 3/2, good. So your r value becomes 3/2. What's your first term? Your first term is -8. Like I suggested yesterday when we were talking about writing out the rules, write out the equations a couple of times. It'll force you to commit it to memory. The nth term, first term, rate, n minus 1. So it's -8 times 3/2 to the n minus 1. And that's my rule. When they want you to figure out then what is the 8th term in that sequence, all you have to do is substitute in 8 for n. So the 8th term, and again, just use your calculator and type it exactly like this, and you won't screw it up. Your calculator will do all the work for you. Oh, fraction then. Math enter. So we got last time. That's all it is. Okay. Then yesterday, think about what we did. Yesterday you were given just the sequence, you were given a specific term and its value. You had to go back and write the nth term. Well, guess what we're going to do today? The same thing. Okay?
You go out like
So, just like yesterday, you were given like the 8th term and you knew that the difference, you were able to substitute in those values, figure out what the first term was, and then rewrite everything. You're going to do the same thing with geometric. Okay? Michael, we're all right? Good? You all right?
yeah, are you about to?
I'm about to switch over.
All right, you
Well, here, I'll do this.
Split screen.
Well, here, let's just take a second, write out the rule for this one first. The sequence is 4, -8, 16, -2, 32. Let's write out the nth rule for that and figure out what the 12th term is. Take a couple of minutes, we got time. Yeah, the universal rule for this one is that a sub n
Ryan.
is always the first term times r to the n minus 1. Always, always, always. Okay? It's a lot of just direct substitution, just like it was yesterday. So let me show you guys what it looks like when it's not, here's the first term, here's your figure out the rate. You got to work it around backwards. When you start messing around with these things a little bit backwards here, you know that the third term is 5, and the common ratio is 2. And it wants you to write out the rule. So just like we did yesterday, we would start out by writing out the equation. Well, a sub n is first term rate to the n minus 1. I'm given the third term, so I start writing that out. First term, rate is 2 to the 3 minus 1. What's the third term? 5. So this becomes 5 equals a to the first. This is 2 squared, which is? What's your first term? 4. Now you know your first term, and you're given your r value, and you put it back together. Wait, what? Huh?
How do you graph this? That's all I-
Don't worry about it. Don't worry about the graphing. We've done this before. This is graphing exponential graphs, exponential functions. These are all just exponential functions.
Also like 5, 4 times 2 to the x minus 1.
Yeah, you've done that. You've done these h's and k shifts before. There's no reason for us to do it again. So when you fill in the blanks, and there's your common rule. Okay? I always think that working with the geometric ones are a little bit easier. You don't have to worry about distributing, because that's where sometimes you guys will miss a sign or something like that. Okay? So let me show you the weirdest stuff that we're going to work on today before we get to the summation stuff tomorrow. We have 2 terms.
Oh, is this the?
This is the type of stuff where you have that system of equations. What you're going to find out with the geometric ones, there's a little twist to it, but it's kind of the same problem over and over again. It's not that bad. What we're going to do here, again, is we're given 2 specific values. We know that the second term is 45, the fifth term is negative 1215. Okay? You could probably tell right now that your rate has to be, well, is it going to be a positive or a negative number? It's going to be a negative number. Okay? So you start with the first value. Start with the generic, write it out. So the second term is the first term times the rate to the 2 minus 1, which means that 45 is the first term times the rate. Everybody okay with that?
Yeah.
Do the same thing with the other one. I know that the fifth term is going to be the first term times the rate to the 5 minus 1. Therefore, negative 1215 is the first term rate to the 4th power. This is the only step you have to make sure you always do the same. Take the first equation that you write out, solve it for a sub 1. Do that every single time. Always, always, always. Therefore, 45 divided by r is the first term. Which means what am I going to do with the second equation? Substitute in. I take this value and I substitute in. Negative 1215 is r to the 4th, oops, 45, r to the 4th over r. Correct. I'm just writing it out longhand first. Yep. So you get negative 1215 is 45 r cubed. And now it's a 2-step equation. What do you do? think it was negative 27. And how do you undo cubing? What's the cube root of negative 27? Positive or negative?
Negative.
Negative 3. So now you know what your R value is. Yeah, Shay. A sub 1. Yeah, what I did here is I got the A sub 1 by itself by dividing by R. Then I substitute that in over here. Okay. So now I know what the rate is. I just use this to figure out what the first term is. The first term will be 45 divided by negative 3, otherwise known as, and there's your first term. Now you know your first term and your rate, and you just put them all back together. Subscript n, first term, common rate to the n minus 1, and there's your answer. Again, when you're working with the two terms, you're going to be using substitution over and over and over again. Always use substitution with the first term. Get a sub 1 by itself. Always, always, always. Okay. That's like the only generic rule that I can tell you on these things. Everything else just falls into place. Let me give you one of these to try on your own, then I'll give you some problems. Oh, go see if you did it right, Dave. Yes, you did it fine. Yes, I did. Go. On the board, go for it. Don't use the. Oh, make sure you're using the regular mark for that. Go ahead.
Don't show me.
That's not personal.
No, it doesn't.
Oh, that's where
Oh, wow. What happens? The equation is a n equals negative 1 times 4 over x minus 1. What is that?
Did you get that?
Got it.
Not you.
I got it. Kill you. Negative 1, 4, and this one.
I got 2
Hey, Mike, what'd you get?
Negative 1, 4,
Yeah. Running short on page. Both of these guys are doing it absolutely perfectly. It's on 670. I want you to do 39 through 53. On 670. You would have built the problem before you got to the board, you would have been better off.
39 through what?
39 through 53. All right. All right.
That's plus
Next time you do it for free.
plus or minus 4?
It was shiny, wasn't it? Section 11.3, page 27, or 670, excuse me. 39, 53. We'll continue this with the summation stuff tomorrow. Gets a little messy, not gonna lie. Okay?
Yeah, it's got a point there.